but the US Space Agency has said that it has successfully reconnected its space probe after a brief scare unexplained.
Voyager has been making new discoveries and sending back pictures from space during a fantastic journey that began way back in 1977.
For over 4 decades, Voyager 2 has been our eyes and ears in the outer realms of our solar system. Its mission, to go where no spacecraft has gone before, and to explore strange new worlds and seek out new life and new civilizations. But what it has found, lurking in the darkness of space, has sent shockwaves through the scientific community and raised profound questions about the nature of our universe. What could this terrifying discovery be? And why did it cause Voyager 2 to suddenly turn back and abandon its lifelong mission? Come along as we explore the shocking new discovery made by Voyager 2, and just why this legendary spacecraft has suddenly turned back for the first time ever. Exploring the cosmos and beyond. In 1965, during a crucial period of human endeavor, a remarkable event unfolded in space exploration. Gary Flandro, an esteemed member of NASA's talented team stationed at the Jet Propulsion Laboratory, was at the forefront of a unique endeavor. His task was both dangerous and innovative, to chart the course of a spacecraft bound for the far reaches of our solar system. Armed with nothing more than a trusty pencil, a symbol of precision in an era before digital technology dominated, Flandro embarked on his mission. Through careful calculations and clever observations, he soon made a discovery that would revolutionize space exploration. Looking into the complexities of celestial mechanics, Flandro uncovered a rare celestial find. Unseen for centuries, his unique discovery involved a rare alignment of gas giants in the outer fringes of space, with Earth at its heart. However, the significance of this alignment extended far beyond its visual glory. It presented a golden opportunity for spacecraft traveling through the solar system. As the gas giants circled in harmony, they created gravitational highways that could propel a spacecraft from one planet to the next, significantly reducing travel time and conserving valuable fuel. Flandro's calculations not only unveiled the potential to shorten the journey to Neptune and other faraway planets, but also revealed a phenomenon known as gravity assists. Gravity assists involve utilizing the gravitational pull of planets to propel a spacecraft, boosting its speed and conserving fuel. This efficient travel technique occurs when Jupiter, Saturn, Uranus, and Neptune align in a specific configuration, creating a celestial highway that dramatically reduces travel time between Earth and Neptune. NASA's decision to seize this opportunity showcased its agility and determination in the face of cosmic challenges, and this was another major objective behind the development and launch of the Voyager spacecrafts. These spacecraft marked a significant milestone in space exploration, but what was more remarkable was their prospective durabilities. Designed to withstand the harsh conditions of space for decades, they were equipped with instruments capable of enduring the passage of time. Despite being launched in the late 1970s, their technology continues to function, although with some limitations due to aging hardware. As Voyager 1 and Voyager 2 journey through space, they carry a special message from Earth. Imagine them as our representatives, equipped with golden records containing sounds and images showcasing the rich style of life on our planet. These records are like a time capsule, preserving a snapshot of who we are as a global community. They're like a message in a bottle, waiting to be discovered by any intelligent beings they may encounter in the vast expanse of the cosmos. But their mission goes beyond just being messengers. Every day, these spacecraft send back valuable data that helps us understand more about our solar system and even beyond. They're like our eyes and ears in the outer reaches of space, providing insights that exceed what we ever imagined possible. Their journey reaffirms the importance of exploring space. With each new piece of information they send back, we gain a deeper understanding of the universe and our place within it. So, as Voyager 1 and Voyager 2 continue their cosmic voyage, they serve as beacons of exploration, inspiring us to reach for the stars and discover what lies beyond. Originally planned to last only 4 years, the interstellar pioneers embarked on an unforgettable journey that stretched far beyond its intended duration. Launched in 1977, the Voyager spacecraft proved to be incredibly resilient explorers, surpassing all expectations and rereading the textbooks of planetary science. As they journeyed through the depths of space, Voyager 1 and Voyager 2 provided humanity with unprecedented insights into the outer reaches of our solar system. These courageous probes captured breathtaking close-up images of Jupiter's swirling storms, Saturn's majestic rings, and the detailed landscapes of their diverse moons. From the icy waters of Enceladus to the volcanic eruptions, each discovery unveiled a dynamic and complex universe that challenged our understanding of planetary processes. Voyager 2, in particular, carved its name in the records of space exploration by becoming the first spacecraft to venture close to Uranus in 1986. Its close encounter revealed a mysterious ice giant surrounded by an atmosphere of hydrogen, helium, and methane. Just 3 years later, Voyager 2 made history again as it passed by Neptune, providing humanity with its first-ever close-up look at the distant blue planet and its mysterious moon, Triton. But perhaps the most remarkable aspect of Voyager's journey lies in its endurance. Despite traveling over 14 billion miles from Earth, the spacecraft continues to communicate with scientists, sending back invaluable data about the interstellar medium it now traverses. These groundbreaking space probes, reflective in size of a vintage Volkswagen Beetle, have surpassed all expectations and continue to push the boundaries of human understanding of the universe. The remarkable journey of the Voyager probes began with a daring gravitational assist from Venus, a maneuver never before attempted by any spacecraft. This decision showcased the innovative spirit of the mission, setting the Voyagers apart as true forerunners in the realm of space exploration. But as the Voyagers ventured deeper into space, it became glaring that the journey ahead was far more challenging. Navigating the dangerous asteroid belt. Navigating through the vast expanse of space has always been very challenging. The room for error was very small, with even small deviations measured in just tens of minutes. This highlights the need for extreme accuracy in interstellar travel. It took many careful attempts to ensure that every aspect of the journey was carefully planned and carried out. As the probes set off on their journey towards Jupiter, they traveled 10 times farther from Earth than the closest planet, Mercury. Their path led them through the challenging asteroid belt, a region of space filled with numerous celestial bodies, each presenting a potential threat to the success of the mission. The journey through the asteroid belt was a topic of intense debate and speculation among scientists and engineers in the 1970s. The exact density and composition of the belt were not fully understood at that time. Despite these uncertainties, the earlier Pioneer 10 and 11 probes successfully navigated through the supposedly dense asteroid belt, proving that such a journey was indeed feasible. This accomplishment not only demonstrated the durability of the spacecraft, but also paved the way for the subsequent Voyager missions. As the Voyager probes journeyed deeper into the universe, they faced numerous challenges and encountered mysteries that presented new opportunities for discovery and innovation. Despite having only 69 kilobytes of memory, which is barely enough to store a small image file by today's standards, these spacecraft embarked on their journey with a memory capacity equivalent to just a fraction of what an everyday smartphone can hold. The engineers who designed these spacecraft showcased incredible imagination. The Voyager probes relied solely on their onboard intelligence to navigate the vast expanse of space. To put it into perspective, it's like charting a course through an endless sea with only a compass and wits to guide you. Before the era of cloud computing and high-speed internet, the data collected by the instruments on board was stored on archaic 8-track tape recorders, similar to the ones grandparents might have used to listen to music in their cars. It's astonishing to think that such outdated technology was responsible for preserving the invaluable scientific discoveries made by the Voyager missions. Despite their limited resources, the Voyager spacecraft communicates with Earth using a transmitter that is only as powerful as a refrigerator light bulb. However, with the help of colossal 12-meter-wide dish antennas, they manage to send and receive signals across the vast expanse of space. Imagine being so far away from home that it takes over 18 hours for a message to reach its destination. That was the reality of the signals sent by Voyager 2 as it journeyed deeper into the universe. Every piece of data, every image, every whisper from these distant travelers had to traverse unimaginable distances before reaching the eager ears of scientists back on Earth. The Voyager probes were launched in 1977 with the primary mission of exploring the outer planets of our solar system: Jupiter, Saturn, Uranus, and Neptune. However, their journey didn't end there. Voyager 1 became the first human-made object to enter interstellar space in 2012, followed by Voyager 2 in 2018. This feat expanded our understanding of the universe and provided valuable insights into the conditions beyond our solar system. Despite their aging technology, both Voyager probes continue to communicate with NASA's Deep Space Network, providing valuable data about the conditions in interstellar space. They have become symbols of humanity's curiosity and ingenuity, showcasing what can be achieved with determination and innovation. The Voyager probes carry a golden record containing sounds and images selected to portray the diversity of life and culture on Earth. This record serves as a message to any potential extraterrestrial civilizations that may encounter the probes in the distant future, offering a glimpse into the rich style of human existence. In addition to their scientific significance, the Voyager probes have captured the imagination of people around the world. Their journey through the cosmos has inspired countless works of art, music, and literature, highlighting the profound impact of space exploration on human culture. As the travelers ventured away from Earth, they faced disruptions from lots of things people made, like radios playing music, TVs showing programs, and the constant noise of cell phones. Despite these challenges, their journeys have beaten the odds and kept amazing astronomers with unexpected findings. Amidst the challenges, Voyager probes dig deeper into space, revealing unexpected mysteries and cosmic wonders. Voyager's surprising encounter with interstellar space. Their journey through space has completely changed how we view the universe. One particular area that's caught our attention is the Oort cloud, a gathering of comet-like objects held together by the sun's gravity. It's a mysterious place that extends halfway to the nearest star and has intrigued scientists for a long time. The Voyage's spacecraft are on their way to explore this fascinating region, hoping to uncover its secrets and learn more about how it shapes our solar system. But before they reach the Oort cloud, they have to navigate through interstellar space. As they journey through this vast expanse, they encounter the heliopause, which marks the boundary between our solar system and the rest of space. This boundary is where the influence of the sun starts to diminish, and the forces of interstellar space begin to take over. Initially, scientists weren't sure how far the heliopause extended, with estimates ranging from 50 astronomical units. This uncertainty sparked increased funding for the Voyage's mission as researchers worked to better understand this crucial boundary. However, when the spacecraft left this significant point, scientists were surprised to find no expected signs of traveling between stars. This unexpected discovery has sparked intense debate and caused researchers to rethink how we understand traveling through interstellar space and the dynamics of our solar system's outer region. Additionally, these journeys have provided valuable information about what makes up the space between stars, giving us a glimpse into the wider universe beyond our solar system. This new information has changed how we see the universe and has opened up new opportunities for exploration and discovery. As the Voyagers continue into the unknown depths of space, they showcase humanity's unyielding curiosity and relentless pursuit of knowledge, pushing the limits of what we thought was possible and unraveling the mysteries of the cosmos. One of the highly expected signs scientists were eagerly waiting for to confirm our journey into the unexplored area of space between stars was the sudden increase in powerful particles called galactic cosmic rays. These particles, often coming from huge star explosions and other massive cosmic events, travel fast. While these cosmic rays pose a big danger to spacecraft and even human astronauts, most of the lower energy particles are stopped by the strong magnetic shield made by our sun's heliosphere. This shield acts as a protective barrier, keeping our inner solar system safe from most outside cosmic dangers. As the Voyager spacecraft continued its never-before-done journey into the area between stars, scientists were not only tracking the rise in galactic cosmic rays, but also looking at any changes in the main magnetic field. This magnetic field is affected by the ionized gases floating in space between stars and nearby stars. The hope was that this magnetic field's direction would be different from the magnetic field inside our heliosphere. Scientists were excitedly watching every discovery, bringing them closer to understanding the secrets of space between stars. The sudden increase in galactic cosmic rays was a clear sign that Voyager had crossed an important point, going into a place where the rules of physics work on a bigger scale. The complex connection between cosmic rays and magnetic fields was an amazing sight, giving us insights into the complicated interactions shaping our cosmic neighborhood. While the danger from cosmic rays was recognized, the wonder of how our heliosphere protects us from most of these particles showed how the forces in the universe work together. With each passing moment, Voyager gave us very important information, helping us understand the detailed workings of space between stars. Scientists eagerly looked at the data, figuring out the clues hidden within the cosmic sounds. The changes in the magnetic field hinted at things we couldn't see, making us curious and wanting to explore more. As Voyager went deeper into the unknown, the excitement grew. What other secrets were there in the big area of space between stars, waiting to be found? The journey was still going on, and every discovery brought us closer to understanding the secrets we didn't know before. With careful work, scientists looked at every piece of information, putting together the puzzle of exploring space between stars. Each observation gave us more understanding, showing us a clear picture of the space beyond our solar system. The journey of Voyager was not just about science. It showed human cleverness and the never-ending search for knowledge. With each new thing we learned, we got closer to understanding our place in the universe, amazed by how big and complicated it is. Despite what scientists expected, the Voyager probes didn't detect any significant changes in the magnetic field as they traveled deeper into interstellar space. This surprising finding baffled researchers and intensified the mystery surrounding exploration beyond our solar system. The lack of anticipated changes raised intriguing questions about the interstellar medium and the interactions among cosmic phenomena within it. This revelation emphasized the intricate nature of space exploration and emphasized the importance of ongoing research and observation to unravel the mysteries of the universe. But just beyond the heliopause, even more horrifying discoveries awaited unraveling. Astounding adventures. Beyond the heliopause. On August 25, 2012, Voyager 1 made history by crossing the heliopause, the outer edge of the heliosphere. This vast bubble of charged particles and magnetic fields is formed by the sun's solar wind. It was the first time a human-made object had ventured into interstellar space beyond our solar system. Voyager 1's journey to the heliopause covered an incredible distance of over 14 billion miles from Earth, showcasing human creativity and the remarkable capabilities of space exploration technology. As Voyager 1 ventured into this unknown territory, it continued to send valuable data back to Earth, giving us insights into the conditions at the outer limits of our cosmic neighborhood. Scientists eagerly awaited Voyager 1's transmissions, hoping to gain new knowledge about interstellar space. They expected to observe an increase in plasma density, which measures the concentration of charged particles. as Voyager 1 moved beyond the heliopause. However, they were surprised to find that there was no significant change in the direction of the surrounding magnetic fields, which was anticipated as the spacecraft transitioned from the influence of the Sun's magnetic field to that of the broader interstellar medium. Fast forward to November 2018, Voyager 2, the twin spacecraft to Voyager 1, embarked on its daring journey to the heliopause. Like its predecessor, Voyager 2 traveled vast distances and sent back invaluable data to Earth, enhancing our understanding of the outer boundaries of the solar system. Upon Voyager 2's arrival at the heliosphere, scientists found themselves once again puzzled by the data it sent back. Like its forerunner Voyager 1, Voyager 2 also noticed no big changes in the magnetic field's direction, which went against existing ideas. This left researchers struggling with new questions about space between stars. These important missions by the Voyager spacecraft not only increased our knowledge of the universe, but also showed the endless possibilities of humans exploring beyond Earth. As these brave probes travel further into the huge space between stars, they act as guides of human curiosity and determination, inspiring future generations to explore the unknown parts of the cosmos. However, current models couldn't explain this interesting difference. When Voyager 2 finally reached its goal, it made a surprising discovery. The solar wind, a continuous flow of charged particles coming from the Sun, was strongest. This suggested that the heliosphere's edge, called the heliopause, might be much farther than previously believed, possibly more than the original 120 astronomical units. The heliosphere, often compared to a bubble around our solar system, is made by the solar wind interacting with the space between stars. It acts as a shield, protecting our solar system from harmful cosmic rays and space debris. Voyager 2's findings made scientists rethink their ideas about the heliosphere's size and how it works. The data it collected gave valuable information about how the solar wind and the space around stars interact, explaining the complexities of our cosmic neighborhood. Also, Voyager 2's long trip into space showed how tough and strong the spacecraft is. Launched over 4 decades ago, these probes still work and send data, going beyond what was expected. As Voyager 2 goes further into unknown areas, it keeps changing our understanding of the cosmos. Its discoveries feed scientific curiosity and push what we know, bringing to mind the big mysteries waiting to be explored beyond our home planet. Besides their importance for science, the Voyager missions have fascinated people all over the world. Pictures and data from the spacecraft have inspired many to dream of exploring faraway worlds and going on their journeys of discovery. As the Voyager probes traveled deeper into space, where the solar wind meets the space between stars, they found a lot of interesting information. Among what they found were small but important changes happening near the boundary of the Sun's influence. These changes seem to be affected by the interactions between the Sun's area of influence and the surrounding space between stars, giving us a better idea of how this boundary area works. Even though there were complex changes on a small scale, the Voyager probes didn't find much difference in the magnetic field far from the Sun. This surprised scientists and made them wonder if the spacecraft would eventually leave the Sun's area of influence and encounter the true magnetic field of the space between stars. Experts argued about whether the Voyager probes might still be within the Sun's area of influence. Making things more interesting, the Voyager probes' journey into the unknown has given us new insights into the outer parts of our solar system. These probes, sent out over 40 years ago, still send back important data to Earth, helping us learn more about space. As the probes went further, they reached areas where the solar wind, a flow of charged particles from the Sun, meets the space between stars, where there's matter and radiation. In this unknown area, the probes made discoveries that challenged what we thought about the edges of our solar system. One of the most surprising findings was the discovery of small but important changes near the boundary, where the Sun's influence ends and space between stars begins. These changes, which seem to be affected by how the sun's area of influence interacts with the space between stars, show how dynamic this area is. Even though these changes are complicated, the Voyager probes didn't find much difference in the magnetic field far from the sun. This surprised scientists and made them wonder if the probes would eventually leave the sun's area of influence and encounter the true magnetic field of the space between stars. This question hasn't been answered yet, which makes scientists wonder more about where the Voyager probes are and what the boundary between our solar system and the rest of the galaxy is like. As scientists keep studying the data from the probes, they hope to understand more about the outer parts of our solar system and how we move into space between stars. The Voyager probes have been around for a long time and have been useful in helping us explore space. Even though they were sent out in the 1970s, they still work and send back data to Earth, helping us learn more about the farthest parts of our solar system. As scientists keep looking at the data from these old spacecraft, we can expect to learn more and understand better how the sun, the area around it, and the space between stars all interact. But it'll appear that NASA saw this coming. Endless quest in the outer space. Evidence strongly suggests that the spacecraft Voyager 1 and Voyager 2 have embarked on a remarkable journey into interstellar space. This evidence includes a significant increase in the detection of cosmic rays from the galaxy and changes in plasma density, indicating a transition into a new cosmic environment beyond the influence of our sun. Solving this enigmatic puzzle surrounding the heliosphere, the region influenced by the sun's magnetic field, is akin to understanding the intricate dynamics of a fishbowl from the perspective of the fish inside. To gain a thorough understanding of this boundary region, scientists recognize the importance of deploying an interstellar probe capable of offering an invaluable external perspective. Amidst the rapid advancement of technology, the Voyager missions stand as remarkable achievements in the history of space exploration, characterized by ingenuity and foresight. These interstellar pioneers are propelled by a blend of vintage engineering and timeless innovation, equipped with instruments dating back to the 1970s. Despite its age, the Voyager spacecraft possesses a captivating charm that fuels the imagination. Their robust structures house precision-crafted instruments, each component meticulously designed to withstand the harsh conditions of space travel for decades. Remarkably, these instruments continue to function with surprising efficiency, showcasing the enduring legacy of their craftsmanship. The power source of the Voyager spacecraft is equally fascinating, utilizing the heat generated from the radioactive decay of plutonium to convert thermal energy into electrical power. This feat of engineering has sustained their missions for over 50 years, enabling them to journey far beyond the confines of our solar system and transmit invaluable data back to Earth. The Voyager missions represent a confirmation of human innovation and perseverance, demonstrating the remarkable capabilities of spacecraft built with limited technology by today's standards. As they venture into the vast unknown of interstellar space, their legacy inspires future generations of explorers to push the boundaries of scientific discovery. NASA's strong commitment to handling the decreasing power of the Voyager spacecraft shows its dedication to maximizing scientific discovery. Every decision by mission engineers is a careful balance between preserving important tools and extending the operational life of these old probes. Despite facing challenges like less power and extreme temperatures, the Voyagers continue to do better than expected. Among the tools on board, the magnetometer and plasma science tool are expected to be the last to stop working. Kept inside the spacecraft's main body, they benefit from the leftover heat made by the onboard computers, ensuring they keep working. Other tools are attached to a 43-meter-long fiberglass arm, stretching the spacecraft's reach into space. If everything goes as planned, scientists predict that the Voyager missions could last until 2030. However, the main worry is still managing power. Despite the difficulties, the Voyagers keep going on their amazing journey, a journey lasting an incredible 16,700 years. Voyager 1 will eventually go past Proxima Centauri, our closest star neighbor, while Voyager 2 will do the same 3,600 years later. After that, they will keep orbiting the Milky Way for millions of years, lasting longer than even our Sun and its protective heliosphere. These tough spacecraft will probably stay mostly whole, showing human cleverness and exploration. Maybe in the far future, they might send a final message into space, although it won't be by radio, and there will be no humans left to get it. The Voyager saga shows humanity's endless desire for knowledge and our determined effort to understand the universe, pushing the limits of time and space itself. Would Voyager 2 ever return to its quest of unraveling the mysteries in outer space? Let us know your answer in the comments below, and if you enjoyed watching this video, make sure to give it a thumbs up and subscribe to the channel.